In this exercise set, we're going to look at how to solve equations involving multiple variables. Now, it may look more difficult than solving a simple equation like we did in the previous exercise set. However, it follows the same concept. So in the first example, I have 1/3 x minus 2y equals 9, and I'm being asked to solve for x. To solve for x means you want to get this x all by itself on one side of the equation, nothing else with it. To do it, you follow the same approach as solving an equation. You have to isolate that x first. So if I take a look, to get this 1/3 x by itself, to get this term by itself first, I have to move this negative 2y to the other side. Well, since it's a negative 2y, I'm going to add 2y to both sides. And that's going to allow me to move it over there. And when I do that, I get 1/3 x equals, now I like to write it in standard form. It's a positive 2y, and then it's a positive 9. Again, look at this. I have a fraction coefficient. Don't divide by a fraction. The more complicated the problem looks, the harder it's going to be. If I divide this side by a fraction, 2y plus 9 divided by 1/3, what does that mean? And so don't just divide by the coefficient always. Look at the coefficient first. If I have a fraction, remember, multiply by the reciprocal, which is really 3/1, but we're in algebra 2. You need to know by now you do not write down denominators of 1. So I'm just going to multiply both sides of the equation by 3. And then the 3 and the 3 cancels. I have 1x, which means the x is all by itself. And then I just distribute the 3, and I get 6y plus 27. So if you were to think about the process that we use for solving equations, I couldn't simplify anything on the left side or right side because these are not like terms. So then I figure out where is my variable I'm solving for, which is x right here. I then get rid of any adding or subtracting going on. It just so happens what you're subtracting by is a variable expression, 2y. But do the opposites. Instead of subtracting by 2y, add the 2y. Get rid of that term. And then you get rid of your coefficient the same way we did before. And so x equals 6y plus 27. Now in this case, I love this case, area of a trapezoid is 1/2 times the sum of the bases times its height. So 1/2 the quantity b1 plus b2 times h. Now in this case, the simplifying may be a little bit more difficult. And if I take a look, and this is the fun way of doing the problem, is I have a 1/2 on the outside. I have a fraction. I need to get rid of fractions. I don't like working with fractions. So that's what I'm going to do first. Now the reason why I know this, and I'm not going to distribute the 1/2 in, because if I do that, look at what happens. If I distribute the 1/2 in, I'm going to get 1/2 b1 plus 1/2 b2. I'm now having more fractions than I originally started with. So I'm making the problem look more complicated. And when you do that, stop. Your whole point of math is to make it look easier. So instead of distributing that 1/2, what I'm going to do is I'm going to get rid of that 1/2. So I'm going to multiply the right side of the equation by the reciprocal, which is 2/1, which is just 2. And if I do that to the right side, I'm going to do it to the left side. Now, this means 2a, 2 times a, so 2a equals, now here's the part I just need you to understand. What does the right side become? If I go through and take 1/2 times the quantity b1 plus b2 times h, and I multiply that entire right side by 2, I'm going to be left with b1 plus b2 times h. You don't distribute it to all the terms. You distribute when your terms have the plus sign in between them. But if you take a look, each of these, the 1/2 is being multiplied by the parentheses. The parentheses is being multiplied by h. So the 2 only cancels out the 1/2. And now if I take a look, I'm still trying to solve for B1, but that B1 is inside of parentheses. If I distribute the h in there, it's going to get more complicated. But if I can isolate this parentheses, get that parentheses by itself, then all I have to do is get rid of this B2. So this parentheses, this object is being multiplied by h. So what I'm going to do is I'm going to divide both sides by h. That will isolate the parentheses. And so I'm left with 2a over h equals b1 plus b2. And in this case, if I want to solve for b1, I'm just going to move the term b2 to the other side by subtracting. So I have, for my final answer, 2a over h minus b2 equals b1. Now, this example was more complicated than the first one. I get it. If I would have gone the same way I did in the first approach, I would have had to do a lot of simplifying at the end. My point in showing you this example is to hopefully open your eyes, because it's very important the further you go in math, that stop looking at the variable when you're trying to solve. Stop looking at just the variable. The further you go in math, you look at the object that contains your variable. And so if I take a look in this example, my B1 that I am trying to solve for is contained in this object. So rather than distributing the 1/2 in and then distributing the h in, rather than doing that, I'm going to isolate the object first and then grab the variable I'm trying to solve for. So that's why I multiplied by 2 first, is to get rid of this 1/2. And I divided by h next to get rid of the h on the outside. And then it was a simple process to go through. So sometimes you're going to have to follow the process that we normally use for solving. But sometimes, and the further you go in math, you try and isolate the object containing the variable you want and then solve from there. So hopefully you found this helpful, and the next process we're going to look at is solving